All right, so this is applications. It's 4 pages of notes, but we're going to do 2 pages for day 1 and 2 pages for day 2. So these are all word problems, and the first line here says, remember, word problems are just puzzles in disguise. Have fun and enjoy yourself. So let's try to do that. Our notes are broken down also into the types of problems. We're going to start with work problems, and we'll also do motion problems in this set of notes. All right, so first off, for work problems, if a job can be done in T units of time, then blank of the job is done in 1 unit time. So to give you an idea of what I mean by this is that if I decide that I'm getting my hair done for prom and the person doing my hair tells me it's going to take 4 hours, how much should she have completed and how much should she be done with of my hair in an hour? She should be done with a quarter of it. So that's the idea here. She should be at least done with a quarter of my hair an hour through the process, right? So more generalized here, if any job can be done in T units of time, then 1 over T of the job is done within 1 unit time, or 1/10 of the job. All right, so here's our first example. It says Jane can wash the windows of a building in 4 hours. Jim can do the same job in 6 hours. If they work together, how long will it take to wash the windows? So what we're going to do is we're going to make an organizational chart here. We're going to make some horizontal lines here. And then on the horizontal lines, we are going to write Jane, Jim, and then together. We are then going to make a couple vertical lines here. The first column is already the names. The second column is going to be the time that it takes each individual, or the togetherness. And then the last column is going to be parts done in 1 hour. Okay. All right, so we said from the word problem that Jane can wash the windows in 4 hours. That means that she can get 1/4 of the building washed in an hour. Jim takes him 6 hours. That means he can get 1/6 of the building washed. Together, that is unknown. We do not know. So that is 1 over we don't know. All right, so now we need to write an equation and solve it. So since this is all in the same unit here, it's parts in an hour, we know that this 1/4 plus this 1/6 must add up to this 1 over x here. And that's the equation that we can solve. Now, the first thing you say when you look at this is, oh, it's fractions. I don't like that. So there is an easy way to solve an equation that has fractions in it. So remember, this is only for equations. What you can do is that you can find the LCD, the lowest common denominator. So if you look, I have a 4, a 6, and an x. So the lowest common denominator for all 3 of them, I can get all 3 to be 12x. Some people will accidentally say 24x, which it's fine because you'll still get the same answer if you don't find the lowest common denominator and just a common denominator, but your numbers will be bigger. So it'll be, just a little more annoying to deal with. All right, so what I'm going to do is I'm going to multiply everything by 12x. You know you didn't get the LCD is if one of your denominators doesn't cancel out. If it doesn't cancel out, then that means that you didn't take care of the lowest common denominator. All right, so now what you're going to do is you're going to simplify each one of these fractions right here. So I can see that I can simplify 4 goes into itself once and 4 goes into 12 3 times. So that becomes a 3x. Here, 6 goes into itself once, 6 goes into 12 twice, so that's a 2x. And then x goes into itself once and x goes into itself once. Remember, this is a common factor right here, so that's why we can cancel the x's out. Now what we're going to do is we're going to write down what we have left. You should have no denominators left if you got the correct LCD. So I have 3x times 1, which is 3x, plus 1 times 2x, which is 2x, is equal to 1 times 12, which is 12. Combine like terms, that's 5x equals 12. Divide both sides by 5, and you get x equals, that goes in there twice with a remainder of 2, so 2.4 hours. So together, it will take them 2.4 hours to wash the windows. Okay? Yes, you can use a calculator, FYI. All right, let's try another one. A swimming pool can be filled by 1 pipe in 10 hours. The drain pipe can empty the pool in 15 hours. If both pipes are open, how long will it take to fill the pool? So really how this question should say is, someone left the drain pipe open. How long is it going to take this person to fill the pool, right? All right, so once again, we're going to do our chart here. And instead of names, we will say the filling pipe and the draining pipe, or pipe 1 and pipe 2, however you want to word it. Okay? So I will call it pipe 1 and pipe 2. And then together. So remember, this pipe 1 is filling it, and this one is draining, unfortunately. It should not be open if you're trying to fill a pool, right? All right, so then our first column is still time, and then parts done in 1 hour for our second column. All right, so let's read through this again. A swimming pool can be filled by 1 pipe in 10 hours. So the rate for the time that it's going to take to fill it is 10 hours. That means that the pool would be filled 1/10 of the way after an hour. Unfortunately, the drain pipe is open too. We don't want that open when filling a pool, but it is. So the drain pipe, it takes 15 hours to drain it. So since we're draining, that means it's losing water, right? So it says -15 because we're looking for time it takes to fill, right? So it'd have to be negative, the opposite of that. So parts done in 1 hour. So by draining it, it's going to lose 1/15 of the pool water. Together, we don't know how long that's going to take. And once again, that's 1 over x. All right, so now we can write an equation and solve it. So we have 1/10 plus -1/15. So we can just change it to -1/15 is equal to 1 over x. And now we need to solve this. So first off, once again, we have to find the LCD. Okay, the least common denominator. So we have a 10, a 15, and an x. We definitely need an x. And then I need the smallest number a 10 and a 15 can be. Don't say 150. That is a number that they can both be, but it's not the smallest. So what you could do if you don't know is that you can take your biggest number and start doubling it and then tripling it and then quadrupling it until you get to a number that the smaller number goes into. So if I take the biggest number and I double it, I get 30, and the smallest number goes into that. So it's going to be a 30x. Multiply everything by 30x. So really what you're doing is you're distributing a 30x to everything, but I'm just going to automatically distribute it like so. Simplify each of your fractions. 10 goes into itself once. 10 goes into 30 times, so that's a 3x. 15 goes into itself once. 15 goes into 30 twice, so that's a 2x. And then I have an x and an x cancel, so that's just a 30. All right, so distribute your 3x. That's 3x times 1, which is 3x. Distribute your -2 times 1, which is -2x. There's an x right here too. And then equals 30 times 1, which is 30. All right, combine like terms, you have x equals 30. So now we have x equals 30 hours, and it takes 30 hours to fill the pool. Unfortunate, right? So by the fact that that pipe was open, it's going to take 30 hours to fill instead of the 10 hours. All right, last work problem here. It says Anne can mow the lawn twice as quickly as Phil. Together they can do the job in 4 hours. How long will it take Phil to mow the lawn alone? All right, so once again, I'm going to make my horizontal lines here. And on those lines, I'm going to put Anne, Phil, and then together. All right, my vertical lines and then my 2 columns. The first one is time. And the second one is part done in 1 hour. All right, so it says Anne can mow the lawn twice as quickly as Phil. So we don't know how long it takes Anne to mow the lawn. And we don't know how long it takes Phil to mow the lawn, but together we know it takes 4 hours. So we know it takes 4 hours for them to do it together. That means if they're doing it together, they can get a quarter of it done in an hour. So we don't know how long it takes Anne or Phil to do it. So we can call either Anne's time X or Phil's time X. It doesn't matter. I'm going to start by calling Anne's time X, and if I want to change it to Phil's, I can. So she can mow the lawn twice as quickly as Phil. So a common mistake people will make here is they'll put an X for Phil instead, and then they'll say, oh, it takes her 2 times as long. It doesn't take her 2 times as long. She can do it twice as quickly as Phil. So if it takes her 5 hours, it takes him double that. So he's the 2x. The part's done in 1 hour is 1 over x, and then this is 1 over 2x. So now we can write our equation and solve it. We have 1 over x plus 1 over 2x is equal to 1 over 4. All right, we need to get our least common denominator, lowest common denominator here. So we definitely need an x. And then we have a 2 and a 4, which can be a 4. So 4x is going to be our lowest common denominator. If you put 8x on accident, you'll still get the right answer in the long run. It's just that your algebra is going to be more difficult to solve. All right, multiply everything by 4x. All right, so in the first equation, the first expression, the x and the x cancel, so I'm just left with the 4 there. And the second expression, the x and the x cancel, and then the 4 over 2 simplifies. 2 goes into itself once, 2 goes into 4 twice. And in our third expression, 4 and 4 cancel. All right, so let's write down what we have left. We have this 4 times this 1, which is 4, plus we have this 1 times this 2, which is 2, equals this 1 times this x, which is x, and we get x equals 6 hours, okay? So I would box this as my answer, but I remember that there was an x here and an x here, and I don't remember which one they asked me to find. If they asked me how long does it take Ann to work, it's 6 hours, but it says how long does it take Phil to mow the lawn alone? So this is Ann. We want Phil, so Phil, it's going to take double that, 2 times 6. So it's going to take Phil 12 hours to mow the lawn. And there's your answer. Okay. All right, the next type of problems that we'll be looking at are motion problems. So it says uniform motion problems involve an object moving at an average velocity or rate and a distance covered in time. The formula that we'll be using is distance equals rate times time. So distance is equal to rate times time. Take your rate, multiply it by your time, and that's the distance. All right, so this first one here says two bees leave two locations 150 meters apart and fly without stopping back and forth between these two locations at average speeds of 3 meters per second and 5 meters per second, respectively. How long until the bees meet for the first time? So what I'm going to do here is I'm going to draw an example or a diagram of what this looks like here. Okay, so we have two different locations. So I'm going to draw a horizontal line here, and we have location 1, location 2. Okay, so there is a bee going in this direction, and there is a bee going in this direction. We want to know where do they meet. Okay, so actually how long until they meet. So like, do they meet here? Do they meet here? Or do they meet right in the middle? Definitely don't meet right in the middle because they're going two different speeds. All right, so here's things that I do know. I know that this whole entire length is 150 meters. All right, so now what I can do is for each bee, I can write an equation using distance equals rate times time. So they're both going two different distances because one's going 3 meters per second, the other one's going 5 meters per second. So I'm going to call this bee's distance 1. And then he's going 3 meters per second. So distance equals rate times time. So his rate is 3 meters per second, and I do not know how long it's taking him. The second bee, I'll call his distance 2, because once again, I don't know how long that is. And he's going 5 meters per second, and I don't know his time. Okay, so what I do know is that I don't know how far each distance that each bee is going, but I do know that the total is going to be 150. Because let's say that they meet right here, okay? This distance plus this distance is 150. So I know whatever their distances are, distance 1 plus distance 2 is equal to 150. Now what I can do is I can use substitution, and I can say, well, this is the same thing as distance 1, so I'm going to replace it with 3t. And then I can say this is the same thing as distance 2, so I can replace this with distance 2. So I get 8t is equal to 150. Divide both sides by 8. You can throw that in your calculator to get your time. And you get 18.75 seconds. So they will meet at 18.75 seconds. Now, if we wanted to, we could also find out how far each bee traveled before they met by plugging in 18.75 here and here, but it didn't ask us for that. All right, next question, or next problem. It says a search plane has a cruising speed of 250 miles per hour. Flying against the wind, it takes the plane 3.92 hours to reach the sinking ship from its base. The return trip to the base only takes 3.08 hours. Find the wind speed. So our unknown right now is the wind speed. And obviously the wind speed is causing a problem one way. It's making it slower and helping the other way because it's making the plane go faster. So our wind speed is what's unknown. I'm going to use W for my variable. W is wind speed. Okay, so I do not know the distance that this plane traveled, but here's what it did. So here's my picture of my plane already. It traveled to a sinking ship, right? Let's say the sinking ship's over here, right? So it traveled there, and then it traveled back. So what I do know is the distance is the same the both ways. So I don't have to call it distance 1 and distance 2. It's the same distance. It's unknown, but that's not a big deal because it's the same distance. So what I am going to do is I'm going to make two equations, both having just a D in them instead of D1 and D2, but one is against the wind and one is with the wind. So I'm going to organize it that way. So I'm going to say against the wind. I'll make an equation and with the wind. I'm going to move this over a little bit. Okay, so distance equals rate times time. The distance, which I don't know, but once again, it's the same as the other distance, so it's fine. I need the rate, okay? So it says it has a cruising speed of 250 miles per hour, but 250 miles per hour, but it is flying against the wind. If it's flying against the wind, that means it's fighting the wind is slowing it down. So I'm going to say that I have to subtract the wind speed off of it, and that's going to be my actual speed, my actual rate. And then times the time, and it said that it takes 3.92 hours. Now I'm going to write my second equation, distance equals this rate. This is when it's going with the wind, right? It says the return trip takes the base only 3.08 hours. That means that the wind is blowing the plane back home. So it's speeding it up. So you're going to take your 250 and you're going to say the wind speed is helping it. And that's why the trip is shorter in time-wise by a little bit there. All right, so now I need to solve for W and I need to solve for W, okay? So what you should notice right here is that these are both equal to D, right? This is equal to D and this is equal to D. If they're both equal to D, they can be equal to each other. It's just using substitution. So I'm going to set them equal to each other. 250 minus W times 3.92 is equal to 250 plus W times 3.08. All right, I'm going to distribute my 3.92. I already have these numbers written out in front of me. So obviously you'll be using a calculator, but I thought it would save on the time of the screencast here. So let me find it here. Okay, so that's 980 minus 3.92W equals, if I distribute this 3.08 here, I get 770 plus 3.08W. All right, I'm going to get all my W's on one side, and I am going to add 3.92W to both sides. And I might as well subtract 770 from both sides while I'm at it. So that gives me 210. 210 is equal to, and then that is no, not point. What am I talking about? I have to add those. Oh, that's 7. That's nice. 7W. I was subtracting in my head at first, so I have to add them. I get 7W. Divide both sides by 7, and we get the wind speed is 30 miles per hour. And that's what it asked us for. If it asked us the distance, we could then plug 30 in, but it didn't. All right, a couple more here. Let's move on to number 6. It says, while driving to Northridge, Mrs. Winters averages 40 miles per hour. On the return trip, she averages 56 miles per hour and saves 2 hours in traveling time. How far from Northridge does she live? So first off, we don't know the distance. But once again, what we know is that if here she's driving to, she drives there and she drives back. It's the same distance, right? So though it doesn't matter, it's very similar to the problem we just had, except for it's asking us for D. So once we have the W, we would plug 30 in here to find it. But it's the same idea. We don't know that distance, but we don't need it, okay, until the end when we need an answer. All right, so we're going to make two equations. We're going to do on the way there and then on the way back. All right, so she obviously is going faster one way than the other way. Okay, so that means her time is going to be shortened. So let's talk about the way there. So we're going to say the distance is equal to, and the distance is equal to for this one because it's the same distance, right? All right, for while driving to Northridge, she averages 40 miles per hour. So that's her rate on the way there. And we don't know the time that it's taking, but let's just say that it's going to take her T time. Okay, and if we want to switch the next one to having T, that's fine. On the return trip, she averages 56 miles per hour, and she saves 2 hours of traveling time. Okay, so if it took her T hours to get there, it took her 2 hours less than that, or T minus 2 to get home. Okay, what we could have done instead is that we could have called this T, and then this would have been T plus 2, because it took her 2 more hours. But let's just keep it the way we have it. All right, just like the last one, they're both equal to that D right there, so we can set them equal to each other. So we're going to do 40T is equal to 56 times T minus 2. 40T is equal to 56T minus 112. Subtract 56T from both sides, and we get negative 16T is equal to negative 112. Divide by negative 16, and we'll get a positive time, which we should, is 7 hours. All right, so if it asked how long did it take her to get there, it'd be 7 hours, 5 hours on the way back. But that's not what it asked us. It asked us how far does she live from Northridge, right? So we need to plug in 7 there, or we could plug it here. It doesn't matter. It's going to give us the same answer because they're equivalent. I'm going to use the first one. D is equal to 40 times 7. And we get her distance is 280 miles. Okay. All right, so the last one, a car traveled due east from a certain point. 1 hour later, another car traveled from the same point. 1 hour later, another car started from the same point and traveled due west. 5 hours after the car started, they were 392 miles apart. The eastbound car traveled 10 miles per hour faster than the westbound car. What's the speed of each car? So lots of information there. The things that I picked up while I was reading is that they traveled 2 different distances. They didn't travel the same distance. Together, it makes 392. So I know this is going to be more similar to the first motion problem that we did. But what main thing that I'm going to do is draw a picture like I did in the first one, because right now I'm a little blurry with what to do. Okay, so here's the point where the cars are leaving from. So it says a car traveled due east from a certain point. So east is this direction. Okay, so I'm going to say a car traveled that direction. I'm going to put an E here to remind myself. Okay, so that's a car traveling one way. So I'm going to say there's a car traveling this way, and they're going to get a distance equals rate times time in a second. 1 hour later, another car started from the same point and traveled due west. So I'm going to have a straight line right here and a car traveling this direction. Put W there for west. And there's a car traveling this direction. Right now, where the point that I have it, it looks like they traveled the same distance, but let's put arrows on the end because I don't know how far they traveled. All right. 5 hours after the first car started, they were 392 miles apart. So I know this distance from here to here is 392. The eastbound car traveled 10 miles per hour faster than the westbound car. What was the speed of each car? So we have 2 distances. We can call this distance 1 and this distance 2, but they're 2 distances, and they're 2 different ones. All right, so now let's get their rate and their time. All right, so let's start with the eastbound car. So it says the eastbound car traveled 10 miles per hour faster than the westbound car, so that's for our rate. So let's give our westbound car rate for R, and then the eastbound car is 10 miles faster than that, so we'll do R plus 10 for our eastbound car. All right, we also need our time, okay? So if we reread this, it says a car traveled due east from a certain point. 1 hour later, another car started at the same point and traveled due west. 5 hours after the first car started, they were 392 miles apart. So I know that the first car traveled 5 hours, right? So 5 hours after the first car started. That was my eastbound car, so that's going to be my time for my eastbound. And it says that the westbound car left an hour later than the first car. So it got 1 less hour to travel, so it is going to get a time of 4. All right, so once again, I don't know these two distances, but what I do know is that my two distances add to 392. So now I'm going to do substitution, and I'm going to say 4r plus 5 times r plus 10 is equal to 392. So what you should notice I did there is I wrote this as 4r, and then I wrote the 5 in front of this so that I don't like it after. All right, so distribute. 4r plus 5r plus 50 is equal to 392. Combine like terms, 9r plus 50 is equal to 392. Subtract 50 from both sides, 9r is equal to 342. And then divide both sides by 9, and you get 38 miles per hour. So it's your rate. All right, let's see if it's asking us for the rate that the westbound car was going. What is the speed of each car? Okay, well, that's the first one. All right, so westbound and eastbound car. All right, so it wants how fast it was going. That's our rate. So the westbound car was going exactly r miles per hour, which is 38 miles per hour. And the eastbound car was going 10 miles faster, 10 miles per hour faster than that. So it was going 48 miles per hour. All right, and there's your motion power problems. All right, you have 2 problems to try for homework tonight. I believe one is a work problem, one is a motion problem.